Section 7.6. Our objective today is I can apply the triangle proportionality theorem and the triangle angle bisector theorem. First of all, we want to define what we mean by divided proportionally. Okay, so let's say that I have two segments, segment A, C, and segment X, Z, and a point B between AC and a point Y between XZ. And if the length of AB is to the length of BC, as the length of XY is to the length of YZ, then we say that segment AC and segment XZ are divided proportionally. Okay, and that brings us to our first theorem, and it is the triangle proportionality theorem. All right, and it says, if a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. Okay, so in other words, there are many proportions that we can set up if we have that situation. So let's say I have this triangle, and I have triangle DEF, and I have segment GH, and it is parallel to EF. Okay, well, notice also that we have similar triangles, so triangle DGH is similar to triangle DEF. And so many of these proportions can also come from their similarity. But we can say that DG is to GE as DH is to HF. So the big part of one side to the small part of the other side is to the big part to the small part. So we set up the proportion large piece to smaller piece is equal to large piece to smaller piece. Okay, but we could also do the small piece to the whole side. So we could say, for instance, GE to DE, and it would be HF to DF, which is the smaller to the whole over the smaller to the whole. Okay? Or we could also do the large to the whole. So we could do the larger piece, which is DG to the whole piece, as DH is to DF. So this is the large to whole equals large to whole. okay? And we could also do small to small, large to large, whole to whole. So we could do GE is to HF as DG is to DH as DE is to DF. So we did small is to small as large is to large as whole is to whole. Okay? So, example. So let's say I have this triangle, and this is parallel to this, and I know that this is 15, this whole side is x, this is 20, and this is 8. Now there's many different proportions that we could set up, but I could, one of them is whole is to large as whole is to large. So whole on the is going to be x is to 15 as 28 is to 20. And again, this isn't the only way it can be set up. It can be set up many different ways. Okay, well, let's go ahead and reduce this ratio, because that's actually going to end up being our scale factor. So 4 goes into both of those, so we have 7 over 5. So we get 5x equals 15 times 7. Divide by 5. X equals 3 times 7, or x equals 21. Okay, so that's one of the ways that we could use the proportion. Another example, if I have this triangle, and this is parallel to this, so that's the key. I have to have parallel segments. So on this one, I'm going to do large to small over large to small. So I'm going to do 33 is to x as 27 is to 18. Okay, and again I'm going to reduce. So 9 goes into both of those. So I get 3x equals 66, so x equals 22. Okay, so that is two examples of how to use the triangle proportionality theorem. Okay. Our next theorem comes from the fact that we know if we have 3 parallel lines, if they cut off congruent segments on one transversal, then they cut off congruent segments on all transversals. So from that, we can get the second theorem, which says if 3 parallel lines intersect 2 transversals, then they divide. Oops. The transversals. Proportionally. Okay, and I'm sorry, this is not a theorem, it's actually a corollary. Okay. So if I have 3 parallel lines and I have transversals, and I know that this is 25 minus x, and this is x, and this is, and I have this transversal, I know this is 16, and this is 4, then I can do, in this case I'm going to do small to big equals small to big. Okay, So I'm going to do x over 25 minus x equals 4 over 16. And again, we can reduce. Then we would cross multiply, so we get 4x equals 25 minus x. Add x to both sides. So we get 5x equals 25, so x equals 5. So it's just another application of the triangle proportionality theorem. Because notice that if you extend the transversals, you'll end up with a triangle. Okay. All right, and we have a final theorem. It's called the triangle angle bisector theorem. And it says, if a ray bisects an angle of a triangle, then it divides the opposite side into segments proportional to the other two sides. Okay. So, for example, okay, let's say I have this triangle, and this side is 27, this side is 45, and this side is 40. And then I have an angle bisector that makes this x, and so this would be 40 minus x. Okay, so this theorem says that x is to 40 minus x as 27 is to 45. Okay, so then I'm going to reduce, so I have x over 40 minus x equals 3 over 5. So cross multiply, so we get 5x equals 3 times 40 minus x. I'm going to continue simplifying. Add 3x to both sides. We're going to get 8x equals 120. So x equals 15. Okay. And notice that since I put this segment first, this segment touches this segment. So it's related to that segment. So that's the one that had to go first on the second proportion. Okay, so let's do one more example like that. So let's say that I have this triangle, and this is an angle bisector, and I know this is 18, this is 24, this is 12, this is x. So I can set up 12 is to x as 18 is to 24. Okay, and again, reduce. So 6 and 8. Oops, didn't reduce enough. So 2 goes into both of those, so it's 3 and 4. So I get 3x equals 48. Divide by 3, so x equals 16.